Bismillahirrahmanirrahim. Hello, my dear students. I hope you are all doing well. I welcome you all in class of O level mathematics. Our discussion is continue on further sets. In last lecture, we discussed about union and intersection and Venn diagram and some basic concepts of this chapter. Today lecture might be a bit long, so I recommend you that you watch this lecture in parts if needed. So, in today's lecture, we will discuss problems related to the intersection of two sets and Venn diagram that include practice now 1 and exercise 1A question number 1 to 3, 7 to 9, 13, 14. And the book that I'm using here, this is the latest edition, New Syllabus Mathematics 8th edition by Dr. Yeap Ban-Har and Dr. Joseph B. W. Giu. To understand today's lecture, we will focus on the following key concepts. You will observe that these key concepts will be used frequently in each question. For a given two sets A and B, we will discuss the following three cases. The first case is when A is proper subset of B. In this case, one circle is inside the other as shown in figure 1. Suppose you have two sets A and B and one is a proper subset of the other. Then your Venn diagram is shown as this. The proper subset A will be inside the other set B. The second case, if A and B are overlapping sets. In mathematics language, two sets are called overlapping if their intersection is non-empty. And neither of the set is subset of the other. That is, A is not subset of B and B is not subset of A. But they have some points in their intersection. While in above case, when A is subset of B, then in this case also their intersection will be non-empty. But in this case, A is a proper subset of B here. So this is the difference. In case of overlapping, both of the circle just intersect each other as shown in this figure 1. And in the intersection, the points will be the points are that points which are the common in both sets A and B. The third case is when A and B are disjoint sets. Mathematically, we say two sets A and B are called disjoints if their intersection is empty. In this case, both circle neither intersect nor lies inside the other as shown in this figure. So these are the three cases that we will focus in each question. This is first practice now exercise that consists on these three questions. In question number 1 of this exercise, it is given that set C that consists on elements A, E, F, G, I and set D is this. In first part, we need to list all elements of their that lies in their intersection in set notation. And in the second part, we need to draw Venn diagram that represent the set C and D separately. The first part, that is C intersection D here. You know, in case of intersection, this is my set C and D. Intersection mean the elements that are common in both sets. The first element is E, that belongs to both of the set, and the second element is G. So their intersection is E and G. Next, how we will draw a Venn diagram? As you see here, their intersection is non-empty. Their intersection is non-empty, and further you can check that neither of the set is subset of the other. Not C is subset of D, and similarly D is also not a subset of C. So this is the case of overlapping or intersecting circle. So in Venn diagram, firstly we draw two circles. The first circle represents the set C, and the second circle represents set D. Now in their intersection area, we will write here two elements that belong to in their intersection, E and G. Now after E and G, the remaining elements in C are A, F and I. We write these elements in set C, A, I, F. And the second set D after E and G have two elements B and H that are here. So this is the easy way to draw a Venn diagram. Next, in the second part. In the second part of practice now one, it is given that set E is set of all elements X such that X, these two dots, you can read these as such that X is a multiple of 6 such that X lies between 0 and 18. 0 is not included here. And F is a set of all multiples of 3 that also lies between 0 and 18. The first part is list all elements of E and F. Here the set E that is actually here in the form of set builder form. This is the set builder form of set builder form. We need to write the elements of set, that is the tabular form. So firstly we write all elements of set E. As set E consists of all those elements which are multiple of 6 and lies between this interval. So we take simply multiples of 6 means first multiple, that is 6 1s are 6, second 6 2s are 12, and third 6 3s are 18. So these are the three multiples of 6 that lies in this interval. Similarly, your set F consists on all elements which are multiple of 3 and lies in the same interval. So we just read the multiples of 3. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18. Now from set E and F, in the second part we need to find intersection. E intersection F, the common elements in both set are 6, 12 and 18. So this is the intersection. Here you can see that your set E is a proper subset of F. And their intersection is non-empty. So this is the first case. In this case, we will draw a Venn diagram like this. This is smaller set E. Inside circle represent the smaller set E, and the outside circle represent the larger set F. Firstly, we write all elements of set E that are actually also lies in their intersection E intersection F. So the elements in set E are 6, 12 and 18. The remaining elements are that belong to set F are 3, 9 and 15. These elements we write here outside the circle E. Now set F, these three elements also are the elements of set F. These are not just a part of set E, these are also the part of set F. because E is a proper subset of F. So every elements of set E is also elements of set F. In the fourth part, is E intersection F is equal to E? Explain. Yes. E intersection F is E because here E is a proper subset of F. That's why E intersection F is equal to E. It is always remembered that when one of the set is a proper subset of the other, then their intersection is equal to the smaller set. In question number 3, it is given that set G consists on all positive integers and a factor of 12, and set H X is a prime number between 5 and 13 inclusive. List all the elements of G and H in set notation. Set G. Set G is a set of all integers that represents a factor of 12. Factor of 12 mean all those integers that divides 15. That divides 12. Divides that divides 12. So the first integer that divide every other integer is 1. The second factor is 2. 2 also divide 12. 12 is also divisible by 3, 4, 6 and 12. So these integer are the factor of 12 and are the elements of set G. Now set H. Set H represent all prime numbers that lies between 5 and 13, and 5 and 13 both are inclusive here. So these are 5, 7, 11 and 13 here. Find G intersection H. This is my set G and the second set H. Their intersection. They have a no common element, so their intersection is empty. So this is the third case, that is case of disjoint sets. This shows that both sets are disjoint sets. Draw a Venn diagram to represent set H and G. As I discussed above, that in case of disjoints, both of the sets we draw separately here, they will then neither intersect or nor any set is inside the other. So this is my set G and this is my set H, and these are the elements of set G: 1, 2, 3, 4, 6, 12, and elements of H are 5, 7, 11, 13. So in practice now one, you see there are the three cases. The first case is case of intersecting circle. The second case is of when one set is a proper subset of the other, and in the third case when both of the sets are disjoint sets. In exercise 1a, we will discuss all of the three cases. In exercise 1a, the problems that are related to the intersection is problem number 1. Here we need to find A intersection B. Here we also require to find intersection E intersection F. While in question number 4, this is the problem of union that we will discuss inshallah in the next lecture. In question number 1, it is given that set A is given, set B is also given. We just need to find their intersection in set notation and draw a Venn diagram to represent the set A and B here. It is given that set A is this and B. We just need to find list all the elements of A intersection B. We just need to find A intersection B. The common elements in both sets are the first element is 2 and the second element is 4. 2, 4, 2, 4. Their intersection is non-empty. Firstly, next we need to find their Venn diagram. So this is the case of overlapping set or intersecting circle. You can see here uh, node A is subset of B, and similarly node set B is subset of A here, and further their intersection is non-empty. So this is the case of intersecting circle here. So this is my set A, and this is my set B, and this is the common area that represents the element of A intersection B here, 2 4. After writing their intersecting elements 2 4, the remaining elements of set A are 1 3 7, and the remaining elements of set B are 8 10. Question number 2. It is given that set C that represents the name of the color blue, green, yellow, orange, red, pink, and the set D yellow, pink, blue. List all elements of C intersection D here in a set notation. C intersection D consists on these three elements, and actually in this question you can see that the set C is the smaller set and it is proper subset of C here. D, every element of D is a part of set C. So D is a proper subset of C here. Uh, as I discussed above, that when one of the set is a proper subset of the other, then their intersection always equal to the smaller set D. So here C intersection D is equal to the smaller set D. Here D is the subset of C, so C intersection D is equal to D here. Draw a Venn diagram. So this is the case when one of the set is a proper subset of the other. So in this case, the Venn diagram is given below here. Smaller set will be inside the larger circle. The inside circle, this represent the set D here that consists of the elements yellow, pink, blue, and the outer circle that represent the larger set C that in this area outside the D, we will write all those elements that are not the part of D but part of C here. So green, red, orange represents the elements of set C but do not belong to set D here. But it is always remembered that all of these six elements, green, red, orange, yellow, pink, blue, all of these six elements are the part of set C. Set C is not consist on just these three elements, green, red, orange. Set C also have yellow, pink, and blue. Question number 3 here. It is given that set E is PQR and set F is ST. In the start of the question, you can see here E and F have a no intersection. They have empty intersection here. It means this is a case of disjoint sets. List all elements of E intersection F. E intersection F is empty. This shows that E and F are disjoint sets. Draw a Venn diagram. In case of disjoint sets, their Venn diagram is like this. This is set E and this is set F. In set E, elements are P, Q, R, and set F, elements are S and T. They neither intersect or nor any set will be a part of the other. Next, we move towards the some hard level question number 7, 8, and 9. Actually, in this question, firstly we list all elements of given sets. In question number 7, it is given that set M consists on all those elements. X is a perfect square that lies between 0 and 70, and N consists on all those elements in which X represent perfect cube lies between 0 and 70. List all elements of M and N in set notation. So in these questions 7, 8, 9, firstly we list every element of M and N, then we find intersection, and in the third part we find Venn diagram. Question number 7 here. It is given that set M is all those integers that lies between 0 and 70 and are a perfect square. What does mean by the perfect square? A number x is called perfect square. X is called perfect square. Perfect square if square root x is a whole number. Is a whole number. Like 1. 1 square root of 1 is 1. Second is 4, whose square root is 2. Third is 9, whose square root is 3. So this is the proper definition of a perfect square. But you can find simply here, because I think this definition is in some way tedious. For example, when you check square root 5 without calculator, it will be difficult here, because square root 5 is a some real number. It is not a whole number. It is not a whole number, because square root 5 is in decimal form. So 5 is not a perfect square here. But the easiest way to write all of the numbers that are perfect square, simply I ask you, what is square of 1? You say 1 square is 1. So the first number that is a perfect square is 1. Second, what is square of 2? You say the number is, your answer is 4. So the second perfect square is 4. Next, what is square of 3? Your answer is 9. So 9 is a perfect square. We will write in the elements of set M are the answer of these square. Next, what is square of 4? Square of 4 is 16. So the next number which is a perfect square is 16. Similarly, you can write all of those elements. 5 square is 25. 25 is also perfect square. 6 square is 36. So 36 is also perfect square. 7 square is 49. 49 is a perfect square. And 64. 8 square is 64. So 64 is also a perfect square. 8 is not a perfect square. Its answer, 8 square. Answer of 8 square is a perfect square. Here our range is 0 to 70. Our range is 0 to 70. So this is in this range, the last perfect square is 64 here. In the similar manner, you can write all of the number that is a perfect cube. The first number is 1 cube. 1 cube is 1. So 1 is a perfect cube. Cube of 2 is 8. So 8 is the perfect cube. Cube of 3 is 27. So 27 is a perfect cube. 4 cube is 64. So 64 is a perfect cube here. 4 is not a perfect cube. We will not write this number 4 in set n. Its answer 4 cube, that is equal to 64. So 64, we write 64 here. Find M intersection n. The elements common in both sets 1 and M and n are 1 and 64. So 164, this is the intersection, that is non-empty. This is case of intersecting circle. You can see here, neither M is subset of n and nor n is subset of M, and their intersection is non-empty. So this is the case of intersecting circle. So this is my first set M and the second set is n. This represents the common area of both sets. The remaining elements in set n are, after deleting 1 and 64 from both sets, in set n we have 8 and 27, and set M have these 6 elements here. Question number 8. X is a multiple of 8 such that lies between 0 and 32 here, and Q is a multiple of 4 here, lies between 0 and 32. List all elements of P and Q. Multiple of 8 means we just read the multiples of 8 like as you read in your table. 8 ones are 8, 8 2s are 16, 8 3s are 24, 8 4s are 32. So these are the elements of set P that are actually the multiples of 8. Similarly, in set Q, all multiples of 4 are 4, 8, 12 up to 32. Find P intersection Q. P intersection Q, the common elements are 8, 16, 24, 32, which is actually equal to P. So this is the case when one set is a proper subset of other. So you can see here P is a proper subset of Q here. So in case of proper subset, the smaller set represent the smaller circle inside the larger circle. So this is my set P that consists on elements 8, 16, 24, and the remaining elements we write outside the set P here 4, 12, 20, 28 that are outside the set P but part of Q here. Is P intersection Q equal to P? Explain. Yes, P intersection Q is equal to P because P is a subset of Q here. Question number 9. R. X is a positive integer and a factor of 18 and S is a set of all elements that are composite numbers between 9 and 18. So firstly we write elements of both sets R and S. Set R, multiples of 18 are. Factor of 18 means all those integers that divides 18. So first integer that divides every other integer is 1. 18 is also divisible by 2, 3, 6, 9 and 18. So these are the elements of set R. Next, the set S consists on all those elements which are composite and lies between 9 and 18. Lies between 9 and 18. So the easiest way is to write the elements of set S by deleting all elements, by deleting every prime number that are in this range. By deleting every prime number lies in this range, the remaining elements are the composite number. So the first number 10, 11 is prime, so left it. Next is 12, 14, 15, 16, these are the composite number that lies in this interval. Find R intersection S. They have no common elements, there are no common elements in R and S, so their intersection is empty, both sets are disjoint. In case of disjoints, we draw both sets separately here. They neither intersect and none of the set is a subset of the other. So this is my set R that consists on 6 elements and set S has these. Next we move towards the very important question of today lecture, and these are very interesting questions and hardest level of this question number 13 and 14. Next let us discuss question number 13 and 14. Both questions are very important questions and are very interesting. In question number 13, it is given that set A is a set of all order pairs. X, y are the coordinates of a point on the curve y is equal to x square minus 3x plus 2 such that x and y are integers. While the set B consists on all order pairs such that x, y are the coordinates of a point on the line y is equal to 0 such that x and y are integers. We need to find A intersection B in set notation. Actually, this question based on coordinate geometry. If you find set A and B separately, you will observe that both sets are infinite sets. But there is no need to find A and B. We just have to find A intersection B here. The concept behind the set A is that it is a given curve y is equal to x square minus 3x plus 2 whose graph is actually a parabola. If you draw its graph, this represents a parabola. While the set B consists on the line y is equal to 0, y is equal to 0 actually represents x-axis. Now, if I ask how much points lies on x-axis, your answer will be there are infinite point lies on x-axis. Like as this is a x is equal to 1. Now here x is 1 and y is 0. Similarly, if this is x is equal to 2, then this is coordinate of this point is x2 y0. So there are the infinite points that lies on x-axis. It means your set B consists on infinite points. Similarly, there are infinite points lies on this curve, but we just need to find a intersection B. We will not find set A and B separately. So how we will do this question here? A intersection B is the set of all those points x, y that lies both on the curve y is equal to x square minus 3x plus 2 and line y is equal to 0. As you know, A intersection B always represents the common points of set A and B. It means we just need to find all those points that lies on both this curve and line y is equal to 0. These points are actually the points of intersection of both line and curve. So we solve both curve and line. This is my curve y is equal to x square minus 3x plus 2 and this is line y is equal to 0. By equating 1 and 2 or by just putting value of y is equal to 0 from equation number 2 to 1, I have a quadratic equation x square minus 3x plus 2. By using factorization, I have two values of x. One is x is equal to 1 and x is equal to 2. So x is equal to 1 and y is equal to 0. There is no need to find the value of y because y is already equal to 0 here. So these are the point of intersection. First is 1 comma 0 and second is 2 comma 0 are the two point of intersection with integer coordinates. One of the important thing is that the condition in the question is that both values of x and y should be integers. As y is equal to 0, which is already integer, and we have found two values of x and x which are also integers. Suppose one of the value here of x is 3 by 2, then we ignore this value. But here x is equal to 1 and x is equal to 2 are both acceptables. So the point of intersections are 1 comma 0, 2 comma 0 represent the point of intersection with integer coordinates. Hence A intersection B is the set of these 2 points. You can understand this question graphically. This is the graph of my curve y is equal to x square minus 3x plus 2. So you can see there are infinite points on this curve, like as this is one of the point here where x is 3 and y is equal to 2. So these coordinates also shows both are the integers, but this is not acceptable because we need to find only the common points between both lines and curve. This is my line y is equal to 0 here, that is actually x-axis. Now this point is not in the intersection, or I can say that this point does not lies on both line and curve. So the 2 points that just lies both on curve and line are, one is 2 comma 0 and other is 1 comma 0. So these are the 2 points that lies on both of the curve and line. So we will accept only these 2 points in their intersection. Next we move towards question number 14. This is also very interesting question and similar to question number 13. Here I have given set C that represent all order pair xy lies on the curve y is equal to x square plus x plus 2, and the set D represent all order pairs that satisfy this line y is equal to 3x plus 5. In the previous question our line was y is equal to 0, but now line is y is equal to 3x plus 5. List all the elements of C intersection D. C intersection D is a set of all points of intersection. We can write just these two lines in the previous question also. Uh, C intersection D is simply the point of intersection of these two lines. So I just find the point of intersection of these two curves, these two equations. By substituting this value of y, that is 3x plus 5 in equation number 1, or by writing equation number 1 and 2, we have x square plus x plus 2 is equal to 3x plus 5. By shifting 3x plus 5 to the left side, I have a quadratic equation x square minus 2x minus 3. By solving this equation either by using quadratic formula or by simply by factorization, I have two values of x. One is x is equal to minus 1 and other is x is equal to 3. In this question, there is a no condition of integer. Suppose if one of the value is here, x is equal to 5 by 2, it is also acceptable here, because in the question it is not given that x and y should be integer. Now, as in this question, my y depend on x here, while in the previous question y is simply equal to 0, that is a constant number. So in this question, I will find value of y corresponding to this value of x is equal to minus 1 and x is equal to 3. When x is equal to minus 1, by substituting x is equal to minus 1 here, I have y is equal to 2 here. And by putting x is equal to 3 in this equation, I have y is equal to 14. So I have two points, minus 1 comma 2 and 3 comma 14 are the point of intersection. Hence, C intersection D is simply the set of that consists of these point of intersection. You can visualize this question in the graph here. This red line, red curve shows the graph of y is equal to x square plus x plus 2, while at this time my line is y is equal to 3x plus 5. From the graph you can see that both line and curve intersect each other at this point whose coordinates are 3, 14, and again at this point whose coordinates are minus 1 comma 2. Although there are infinite points lies on both curve and line, but we do not need to find these points here. We just need to find point of intersection here. So I hope today lecture is helpful for you, and if you find my videos, my lectures are helpful for you, kindly like, share. In the next lecture, we will discuss all the problems that are related to union. We will discuss that problems. So see you in the next lecture. Okay, take care. Allah Hafiz.